Hello and welcome to Viptela technology demonstration video. Let's now discuss the case of bandwidth augmentation. In this case, we have an organization which is leveraging an MPLS for network connectivity. When the network bandwidth becomes exhausted, applications start experiencing degraded performance. Internet circuit is provisioned to provide additional network capacity with Viptela's virtual fabric seamlessly extended across both MPLS and Internet. Bandwidth-intensive applications are rerouted over the Internet and performance is restored. In our initial setup, we have two locations, a remote site and a data center with an MPLS network providing the connectivity between the two. Remote site has a 2 megabit link and Viptela solution is deployed to provide a virtual fabric on top of the MPLS network. There are two application flows between the user at the remote site and the application server residing in the data center. The first flow consumes 1 megabit of bandwidth. The second flow consumes 2 megabit of bandwidth. Flow 1 has a higher priority than Flow 2. As we mentioned earlier, total MPLS link capacity at the remote site is 2 megabit, so both flows cannot fit in. Since Flow 1 has a higher priority, it goes through in its entirety. However, Flow 2 only consumes the remaining 1 megabit. It experiences around 50% packet loss. Let's now add a 10 megabit internet circuit to augment the network capacity and seamlessly extend Viptela's virtual fabric solution across both MPLS and Internet. A 2 megabit flow is rerouted from MPLS to Internet, and since bandwidth is plentiful over Internet, flow number 2 now receives a full 2 megabit of bandwidth it requires. A packet loss stops. Let's now see how it's actually happening. This is Viptela vManage, a single pane of glass for managing and monitoring the entire Viptela solution. Let us first check and see that we only have an MPLS network available to us between the remote site and the data center. Let's navigate to Monitor, Network, and choose the device that represents the VH at the remote site. Click up. As you can see, we only have an MPLS connections. These are the connections between the VH at the remote site and other VHs in other parts of the topology. Let's now start an application flows. We're going to be leveraging an iPerf and JPerf tools for that purpose. An iPerf client is going to be running at the remote site, and a JPerf server is going to be running in the data center. JPerf will allow us to visualize the results. We already have two JPerf instances running. JPerf instance number 1 listens on port UDP 5001. JPerf instance number 2 listens on UDP port 5002. Both JPerf instances are ready to accept the connections. Let's start the actual application flows. This starts a flow to UDP port 5001, and it is a higher priority flow. This starts a flow to UDP port 5002. It is a lower priority flow. Let's see what happens on the JPerf. Flow number 1 receives the 1 megabit of bandwidth it requires. However, flow number 2 receives only around 900 kilobits. This is less than the 2 megabits the flow actually is. This is because the MPLS circuit is saturated and we cannot accommodate both flow number 1 and flow number 2 at the same time. Let's now enable an internet circuit. Let's go back to vManage, go to Configuration, Templates. We have already created a template ahead of time that enables an internet circuit. We can see what the template is going to configure. Let's attach the devices to the template. Let's choose the VH at the remote site. The template is now being applied to the VH at the remote site. It is complete. What we expect to happen now is that we expect the internet circuit to be enabled at the remote site. Let's validate. Let's go back to Monitor, select a network, and again choose the VH at the remote site. Now click up. As you can see, we now have connections for both MPLS and the business internet. This allows the remote site VH to send network traffic over both. Let's now change flow number 2 and make sure that it goes, instead of an MPLS network, it goes over the internet. For that, we will go to Configuration, Policy. We have already created a policy that is going to do this for us. We can see what the policy is going to do. Let's activate the policy. As the policy is being activated, let's go back to the JPerf instance that shows us flow number 2, and let's observe the bandwidth. As you can see, we are still at 800 kilobits, and then the bandwidth ramps up to 2 megabits. This is exactly how much flow number 2 receives. The reason for the ramp up is because the flow is now going over the internet circuit instead of the MPLS circuit. The bandwidth is plentiful over the internet, so flow number 2 receives exactly what it needs. In conclusion, Viptela's secure extensible network technology allows you to seamlessly augment network capacity across any set of transport, and by that improving an overall application performance. If you would like to learn more, please visit us at Viptela.com. This concludes our demonstration. Thank you for listening, and see you in the next video.